Good afternoon, Anna, everyone. Yes, yes, good afternoon. All right, will we start the class now? Yesterday, I think, yeah, yesterday, I think we stopped at somewhere in finding out the tension and acceleration due to gravity in case of connected bodies. Okay, good. On inclined plane, yeah, yeah. On inclined plane also, I asked one question. Right, right, right. Okay, then, no problem. Triangle was given angle alpha and beta. Yes, yes, sir. I think we completed that question, Anna, by giving like alpha. Yes, alpha 30 degree. I think got 60 degrees and beta 30 degrees. Yes, yes, yes. I think even this model also I completed. Like here connecting two masses, like suspending two weights here. Yeah, this model is also completed. Yes, yes, yes. Okay, good. So next we are moving to here the models like for example, suppose sometimes not so easy to find out the accelerations of connected masses. Okay, sir, how, sir? Suppose here, suppose I take for example, I think you can say the answer for this question, I believe. Okay, sure, Nana, sure. This is a support, and from the support I take a string and some load is suspended here. Okay, and in the string I take that the string is massless now. Okay, at some point, okay, here I'm applying some force towards right. Okay, I'm saying that not exactly at the center, somewhere. Okay, I'm not giving that distance also. Somewhere in the string I applied a force like this. By this, what happened? The upper part tries to move towards right. Okay, tries to move towards right means here the string will come to this position, the upper part of the string. But I think since I suspended here some load, it will be vertical only. Here the lower part will be appeared like this. Is my diagram correct? When I apply some force here, suppose the points are, yes, points are A, B here, and this is C. C to D, it is moved by applying some force. Of course, in continuation, I am extending this line. Okay. But he is saying that I am able to move up to this position only. Further, it is not coming forward with the same force. I am not increasing the force, I am not decreasing the force. Constant force I applied. It comes to that position and stops there. Like in the park, suppose someone sit in the cradle and we try to pull that cradle to the other side. Swing, Nana, what I'm saying. Suppose someone sit in the cradle and we try to pull the swing away from the position, and we can pull that person to certain position only. Later we can't pull, we leave him. Then he will make the oscillations. Am I right? In the same way, here you applied some force. Okay. Whereas this is the load, what I took here. And that load is suppose come capital M here. If after pulling aside at the position D, the system is in equilibrium. Okay, system is in equilibrium. Find the angle made at A, and made at A means with the vertical, and the tension in the string, okay, AD and ABCDE and DE, AD and DE. Okay, neglect the mass of string. Of course, as usual, it is considered as inextensible string. Okay, any ideas do you have here? Okay, I'm moving to the solution. Here, no one is responding. So first of all, what are the forces I'm trying to identify? May I take first the weight of the string mg downwards? Okay. And here the tension in the string says some T dash, right? This is mg. Here in the string D is some T dash. And here action and reaction, this is T dash. And when you try to pull this side, immediately some tension will be developed here. This is some T, action and reaction, here T, okay. And this T is making some angle here with the vertical. That angle at A, what he asked, find the angle made at A. At A, suppose if I take the angle as theta, so shall I take angle is also theta? Is it correct? I think it is correct. Then you may ask, sir, why you are taking the angle here? Why? Because T dash is vertically downwards along y-axis. F is exactly along x-axis. But T is neither along x-axis nor along y-axis. That's why I'm taking this angle. I'm going to resolve the T into two components. Okay. So here the other component I will get along this line. Yeah. And net force will be 0. Yeah. Why? Because it is in equilibrium. That I understood. Here this will be T adjacent side. So cos theta, and the other component is T sin theta. Okay. All right. No, not T. In my assumption, this is T dash. T in equilibrium means here in FBD1, what I'm going to identify here. This is FBD1, free body diagram. Okay. In that FBD1, I am finding out in the solution in F net equals to 0. Why? Because he clearly said it is in equilibrium. It is in equilibrium means F net equals to 0. F net equals to 0 means mg minus plus actually opposite direction minus T dash equals to 0. So that T dash equals to mg. Is it correct? Babus and babies, please respond. Amaya Babu responded. Where is baby? Amaya babies also started responding. Okay, good. So T dash equals to mg. Good. And then look at the point D, Nana. This is equation 1. Yes. And if I come to here, where here, who is this? Madhuri. Then here, if I come to at the point D, yes, Meher, Mr. Meher, very frequently you are opening your video. Right, at the point D. Along x-axis and along y-axis, I think, okay, Nana. Along x-axis and along y-axis, if you see, left-hand side and right-hand side, since it is in equilibrium, F net equals to 0 surely. Along x and y-axis, so I can write, thus, I am writing here, along x-axis, F towards right, and T sine theta towards left. So minus T sine theta equals to 0. And along y-axis, mg downwards, T cos theta upwards. So T cos theta plus downwards, I am finding out this is actually T dash, Nana. T dash equals to 0 at the point D. Any corrections are required here? Along x-axis and y-axis are both are correct. Are the two equations correct, Nana? Correct only. Very good. Very good. Yes. Minus. Right. Oh, here minus T dash. You are right, Lakshmi Gayatri. Yes. So from these two equations, I am writing here F is equals to T sine theta and T cos theta is equal to T dash, where T dash equals to mg. Since T dash equals to mg. Okay. So look at my question. Find out theta. Theta means divide the two equations. That implies t sine theta by t cos theta equals to, I'm going to get here f by mg. So tt get cancelled. I'm getting tan theta equals to f by mg. Is it correct, Nana? Or any correction is there? Correct. Okay, good. And by squaring and adding these two equations, okay, that implies t square sine square theta plus t square cos square theta. I will get t square sine square theta is f square plus t square cos square theta is mg whole square. If I take t square common, sine square theta plus cos square theta is 1. Then you will get t square is equals to f square plus mg whole square. Therefore, I am getting t is equals to under root of f square plus mg whole square. Okay. What he asked, look the two equations. Root of f square plus mg whole square. Right, good. That's what I got here. Okay. Now related to this question, one student posted in our WhatsApp group what he said. In the above example, yes, in the above example, why? Because here he did not give the numerical values. So you may consider it as a formula. Suppose that's what I'm asking here. In the above example, given that F is equals to 60 newtons and M is equals to 5 kg, take G is equals to 10 meter per second square, find theta and T. Then I think from the above explanation, you can say the answer very easily for this question. Yes, will you post the two answers now? Yes, that is 60.41. Tension, I think you posted. Okay. I think this is wrong, Nana. Amok? I think, yeah, wrong. Lakshmi Gayatri, tan inverse 6 by 5. Yeah, exactly, correct. Yeah, now it is correct, tan inverse. Yeah. Tan theta is equals to, I told that F by mg. That is 60 by 5 into g is 10. So tan theta equals to, you got 6 by 5. So theta is equals to tan inverse 6 by 5. Very good. One is correct. And what about tension, Nana? Okay. I think Lakshmi Gayatri correct. Root of 61, 78. Yeah, both are correct. Amog also correct. Yeah. Now it is correct now. Root of, I said, f square plus mg whole square. Okay, that is root of 60 square plus 50 square. Okay, few students done like by taking 10 square common. 10 square is taken out means that becomes 10. Root of 6 square is 36, 5 square is 25. They have done like this, root of 61. This is correct. And root of 61 is 7.81. Okay, so that one, or you can write it as 78.1 newtons. Both are correct answers, 78.1 or 10 root 61. Okay, good. Then What is the complexity in this problem, Karapudi? Mr. Karapudi? Right, right. Okay, it is easy only. Right, right. You ask your friends, Mr. Aditya, they will tell who is Karapudi. Right. Then what you ask? Okay, right, right, right. Then here, come to the next one. Here, these type of questions, Nana. Okay, actually, they are important, such type of models. Actually, I planned to explain that one today, but unfortunately, a bit earlier, one student asked, okay, no problem. That's not an issue. Here, suppose from the support, if I take two pulleys, here like this is one pulley, and I took here another pulley. Actually, we see this type of system in the gyms, Nana. Okay, for exercise purpose. Okay, usually we sit on a stool, and with the two hands we hold two rings or two supports here, and the back of the person there will be some weight. Okay, that weight is connected to these two ropes, and by pulling these two ropes down we have to lift that weight upwards. This is one exercise actually there in gym. Those who are here regularly go to gym, they know this exercise actually. Okay, yeah, crunches, yeah, exactly, that is correct, crunches. Okay, that crunches exercise here, I'm asking related to it one question. Yes, this is the weight what the person by pulling these two ropes down, lifting the weight here, right, to get a 6-pack or 8-pack or 12-pack. Okay, they do this kind of exercise usually. Yeah, correct. Oh, surely. Yeah, for us it is family pack. For them it is 12-pack. Right, coming to here. Yes, this is the way what we are pulling. Okay, the question is, suppose if you pull these two ropes downwards with the same constant velocity or acceleration, whatever it may be. If I give here, those two are pulled down with the same velocity by holding the two ropes simultaneously, then with what velocity the weight will go up? One question. Or if both are pulled down with the same acceleration A, what will be the acceleration of the weight? Means model will be same. That's what I'm saying here. Okay. In this case here, if you observe properly, here and there, yeah, correct only. Oh, I think you asked me this question to test my knowledge, Mr. Karpode. Uh-huh. Okay, right. If you know the answer, then why you ask me? Right. Okay, good, good, good. Uh, do you have a chance to unmute your voice? Do you have that option or not? Ah, okay, okay. Yeah, I will give the permission if you have that option. Okay, right. Then try it now. Not Shakespeare. No, 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 no. Now you can try, Nana. I gave the permission. You are not trying. Okay, leave it. No problem. Then here, coming to this question, my question is, if this by pulling these two ropes down, again consider the weights of. Yeah, I gave the permission, Nana. You can unmute. Okay. Once again, you try it now. Oh, okay, okay, no problem. Then it is okay. No issue, Nana. I will explain. Okay. Consider the masses of the strings zero, Nana. That is like weightless and inextensible strings, massless and inextensible strings. Okay. Now look at this question properly. Suppose if I extend this line, okay, like this, and here extending this line here almost by neglecting this distance here. Okay, I think you are seeing some one right angle triangle. Okay, in this right angle triangle I am neglecting the upper part, means this part you observe, this distance is always constant even though the weight comes up and suppose comes to this position even. Again, if you try to construct the right angle triangle, this distance will be constant. Will you accept that one, Nana? Which distance here says some from A to B? What I'm saying. AB is a constant. Will you accept? Respond. Accept it. Okay, good. So here A and B is constant. Okay. In the above figure, if the ropes are pulled down with the same velocity, simultaneously, then the velocity of block is. It is the question. Okay. Suppose its velocity at the given instant is v dash. Okay. And here, suppose if I take angle at one side is theta, means half vertex angle here, half angle is theta. Then in ABC triangle, shall I write, suppose by taking here the point as C, shall I write AB square plus BC square is equals to AC square, Nana? Is it correct? Yes. Now this is from right angle triangle ABC. Now I'm going to differentiate this equation on both sides. Like d by dt of plus bc square equals to d by dt of ac square. Then you may ask, why are you differentiating this equation, sir? First, you wrote using the right angle triangle concept. Python hypotenuse square is equals to side square plus side square. I accepted that, sir. Okay. But why you are differentiating? You observe here, while it is going up, theta is changing, means here the values are changing, except AB, BC and AC are changing. BC is gradually decreasing, AC is also gradually decreasing when the weight goes up. Okay, so these two values are changing with the time. Changing with the time means I have the option to differentiate with respect to time. Okay, did you follow my explanation, Anna? I explained why I am differentiating that equation. Yes, good. Now here, now I am going to the separation rule. D by dt of AB square separately plus d by dt of BC whole square separately is equals to d by dt of AC whole square. Okay, this one straight away I write it as 0. Why very good, Amok. Why I wrote it is 0? Since AB is a constant. Very good. AB is constant. Constant differentiation of constant is 0. Yes, correct. Differentiation of constant is 0. Yeah. Plus, yeah, this one you write here like d by dt of x square. Okay. AC is not constant, Nana. AB is constant. Right. Here BC directly I'm differentiating, Nana. Okay, that is 2 times of this is BC into d by dt of BC. First, you understood this step, Nana? Yeah. Not integration, Nana, differentiation. Like d by dx of x power n is equal to n x power n minus 1. If both are same, if both are not same, d by dt of x power n, x, different terms, nx power n minus 1 into extra, we write d by dt of x now. In this way, I differentiated the equation. N is 2, Nana. So 2 into bc power 2 minus 1. That is bc. Yeah, good. So 2bc into here bc and dt are not same terms. So extra I have to write here like d by dt of x. D by dt of x is bc. Okay. If you understood this part, you say the other part here. D by dt of ac square means like x square. d by dt of x square. Yeah, good. 2x into dx by dt. Yeah, in the same way here, AC, 2AC, 2x into dx by dt, d of AC by dt. Yes, yes, yes. That's what I did here. Okay, na? Good. This is the hint what I gave here. Okay, leave it. Right? This hint I will leave. I will keep here. Okay, the same hint I applied here in this equation. Okay, right, good. Then d by dt of BC means who is moving in this BC direction? The block or the two ropes? The block. So d by dt of distance is velocity. Yeah, the velocity. Velocity here, velocity of block is v dash. Yeah. So shall I write right here in the next page? This is 2 into BC into that is V dash. Is it correct, Nana? 2 into BC into d by dt of BC. That is velocity along BC line. That is V dash. Will you accept? No response? Accept. Okay, right. Good. And the other side here is equals to 2AC into d by dt of AC. In this line, who is moving? Rope or block? Along this line, who is moving? Is it rope or block? Rope. Blocker. Along this AC line, Nana. Rope. Along BC line, block is going up kada. Right. Rope. Rope velocity is V. So I am writing here d by dt of AC is V. So 2 here get cancelled. 2 cancel here. And you are getting, I require V dash, Nana. V dash is equals to V into BC by AC. Okay. BC by AC means, look at in the triangle, BC by AC from the triangle, I will get by writing cos theta value. Cos theta from the triangle is equals to adjacent side BC by hypotenuse AC. So BC is equals to, I'm getting, sorry, that value is cos theta. Okay. So shall I write here V into BC by AC? Sorry, I got actually AC by BC. Yeah, I forgot in seeing here. V into AC by BC. That is equals to V divided by BC by AC. Okay. Now BC by AC, I am replacing with cos theta. Yes. Therefore, I got here V dash is equals to V by cos theta. Okay. Do you have any doubt in my explanation, Nana? Or understood this problem, how I calculated? Yes. And here, Mr. Amog, you said that you can resolve it into two components, but we should not resolve it into two components, Nana. The components of the strings will be m cos theta, and on the string moving with the same velocity, use of speed, m cos theta is equals to u. So v is equals to u by cos theta. See here, Nana, if you resolve what you are saying, v dash, if you resolve that into two components means, if I resolve it into one component, you will get here v cos theta. and that V cos theta is equals to V, you are saying. Okay, then here V dash cos theta. V dash is equal to V by cos theta. Okay, what about the other side in your explanation? That is not you. Then who is that? I will see now. Check. I will check it. Oh, this is Manikanta. Okay, okay, okay. Manikanta, I think your method is wrong, Nana. By seeing that like that, you are saying V dash is equals to V by cos theta. Okay. If V cos theta is coming in this direction, where is V sin theta? V dash sin theta. V dash sin theta will come in this direction or some other direction. What about a V dash cos theta, V dash sin theta? These two are not perpendicular, Nana. Who said these two are perpendicular, the two ropes? So I think you won't get in this direction V dash sin theta. So resolving V dash into two components is a wrong method. Maybe unfortunately by taking one component here V dash cos theta, you may get the answer, but it is wrong. Now you understood where you did the mistake? Or else still do you want to say anything? Okay. In this method also. Okay, right. This method is correct. What in this method, suppose if you did, this is correct. Okay. Here exactly AB is constant. So exactly by doing the differentiation, you will get the answer. Okay, good. And here, remember, keep in mind, it is very important what I'm going to say. The shortcut for such type of problems. Here, if one mass is influenced by two things here, okay, in that case, keep in mind the tension in the string is an internal force. Okay, it is inextensible. Who it is means, again you may ask. String is inextensible. That implies tension is not elongating. Not elongating means, keep in mind, there is no displacement by the tension, is not elongating the string. There is no displacement by the internal force. That implies S is equals to S displacement. Okay, equals to 0 by the tension. By a force displacement is 0, then the work done by it equals to 0. Why? Because work done is equals to force into displacement. I think no need to explain. Do you know this formula, Nana? Yes. And here keep in mind both are vectors. Vectors, but work is a scalar. That's why we have to take scalar product, means a dot product between those two. That's why I write here F bar dot S bar should be equal to 0, where F bar is the tension, that is internal force. Yeah, that's what I'm saying. Okay, you have W is equal to Fs, but after discussing that cross product and dot product, both we completed. There, this is one example for dot product, F dot S. Okay, right. So here, F internal dot S equals to 0 means T bar dot S bar equals to 0. If I differentiate this term, I will get T bar dot ds by dt bar equals to 0. That implies I write here T bar dot ds by dt is velocity equals to 0. One more time, if I differentiate, what I will get T bar dot dv bar by dt equals to 0. dv bar by dt is acceleration. So I will get T bar dot a bar equals to 0. So all together in three shortcuts for the tension under those conditions. Which conditions? The intention in the string is an inextensible, is not extending the string. Provided under this condition. Okay, now you understood here, Nana, my explanation, shortcut explanation. Yes, shall I move further in continuation? Okay, then here, look at the diagram. Here, this is V dash, and this is completely one string. Okay, so here I am taking the diagram. That is nothing but work done is equals to 0, Nana. That's what I wrote here. Acha, okay. What I said, T bar dot S bar equals to 0, or T bar dot V bar equals to 0, or T bar dot A bar equals to 0, provided the tension is not elongating the string. That's what I said for the shortcut. Means these three you can use as a shortcut once you check whether the tension is elongating the string or not. If it is not elongating, you can use the three shortcuts. Now you understood? Means indirectly what I'm saying, in case of spring, don't use this shortcut. Yeah, don't use this shortcut. In case of spring, if you stretch, spring elongates. In this case, T dot S sir, I use equals to 0 means that is wrong. T dot V, if I sir, I use 0, sir, wrong. T dot A equals to 0, wrong. This is in case of spring. Yeah, that's what I said. Clearly, tension is not elongating the string. In that case only, we use these three shortcuts. So note, better I write here, note. In case of spring, the shortcut is not valid. The shortcut is not valid. Now, is it clear, Nana? I think you don't do any mistake here related to spring and string. Okay. Good. Come back to the question here. Yeah. String is not elongating means V is not equal to 0, Tali. string is not elongating means that tension is not creating any velocity to the molecules. That's what I'm saying. Not to the body. It is giving some velocity to the body, not to the molecules existing inside the string. Now is it clear, Lakshmi Gayatri? Okay. Even though if there is spring one place, that I will explain it later. First, try to complete this one. Okay, then come to here. Lakshmi Gayatri, I think now you can understand once you see this diagram. Now you may get some clarity here. Yeah. Right. No, 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 no. Now come to here the diagram, Nana. These are the two velocities at the two ends. But the separation between the molecules while pulling the string down is not changed. Means all the first molecule suppose goes down by a distance of 10 centimeter. Second molecule is also coming down by 10 centimeters. The separation between the two is not changing. Now is it clear, Lakshmi Gayatri? So each molecule is having some velocity, but the separation is not changing. Separation is still 10 centimeters only. That is what I said. Tension is not elongating the string, not increasing or decreasing the separation between the molecules. Okay. Yes. Intermolecular. Yeah, intermolecular velocity. But here this V is not intermolecular velocity. That is velocity of the string. That's why here you should not link both. Yeah, that I accept. So I think now you understood. Okay. Right. Come to here. And this is the tension in the string at the left side here. And coming to there, same string here also. So same tension, but making at that instant an angle theta. Okay. This is the velocity of the block. V dash. This is V dash. And here in continuation, we are taking the string to here, same string. So same tension here, T, and passed over pulley. And here also same tension. This is the left side part. And downward the velocity is V. Now you understood clearly the tensions and velocities here, Nana. And here also the same angle theta. Why? Because it is going vertically upwards. So the two angles are equal. Okay. Any doubt here in the diagram? Any doubt, please? No. Right. Now, this tension is not increasing the intermolecular separation. So for the whole system, I can use the second shortcut, algebraic sum of T dot V equals to 0 for a system. Okay. So for a system, I change it as sigma. Okay. In this system, how many parts are there, sir? 1 part, 2 part, 3 parts, 4 parts. Total 4 parts are there. Okay. I think still you have some doubt in mind. Okay, look at here what I'm going to write. That implies T dot V, that is TV. What will be the angle between these two here, Nana? How much is this angle between T and V? 180. Very good. TV into 180 here. This part is over. And here, last part. Shall I write again TV cos 180? Yes. And here T and V dash, what is the angle? Theta. Here. Theta. So TV cos theta. There also T and V dash angle is theta. Yeah. TV cos theta. So for all tensions, I wrote T dot V dash. Now is it clear, Nana? This is the shortcut of T dot V. How many tensions are there in the whole system? For all tensions, write T dot V and algebraic sum equals to 0. Here 4 T dot V's are there altogether. So T dot V here, T dot V there, T dot V here, T dot V here. All together algebraic sum plus. Okay, if you understand this step, then in just 2 steps you will get the answer. Avoiding the differentiation, right angle triangle, this whole explanation you can avoid. This whole explanation just in 2 steps you can say the answer. Okay, this is TV cos. Sorry, I forgot here writing cos. Cos 180, yeah, cos 180 is -1. So minus TV plus TV cos theta, TV cos, sorry, this is V dash, na? One more thing I missed here. This is V dash, sorry. And here this is plus TV dash, 2 TV dash cos theta. Okay, again cos 180 is -1. So minus TV, right, is equals to 0. Simple, throw the 2 negative bodhis to the other hand. You will get 2 TV dash cos theta is equals to 2 TV. Then 2T cancel. What do you want? V dash. That implies I got the answer. V dash is equals to V divided by theta taken to the other hand, cos theta. You got the answer or not? Okay. Yes, so it will a big shortcut for many numericals which are appear to be complicated. Okay, those complicated sums we solve in very simple manner by using our shortcuts here. What are those complicated problems are? In next class we will discuss. Yeah, V dash is equals to V by cos theta. That only I wrote. Okay. Tomorrow do we have classes, Anana? No. Okay, then we will meet on Friday. System ante nothing but number of bodies connected to the string, Nana. Combination of blocks or bodies is called as system. That is system. That's it. Okay, right. Okay, Nana. If you want the pages, this is the first page. Second one. And third one. That's all. Thank you, thank you, thank you. Same to you all. Okay, bye now.